Good morning, students. Today we discuss about the topic of electric conductivity of solids. Electric conductivity of solids. Okay, solids. The conductivity of solids is three types by based on electric conductivity. The conductivity of solids is three types or three categories by the based on electric conductivity. What is that? The first one, insulators. Second one, semiconductors. Third one, conductors. Okay, students, very most important, electric conductivity of solids. The conductivity of solids is mainly three categories by the based on electric conductivity. Okay, the first one, insulators, semiconductors, and third one, conductors. These electric conductivity range, I mean resistivity. The resistivity range of insulators, semiconductors, and conductors is, the first one, insulators, is 10 power of minus 20 ohm inverse centimeter inverse to 10 power of minus 10 ohm inverse centimeter inverse. Ohm inverse centimeter inverse means that is resistivity. Okay, students, resistivities are electric conductivity range. What is the electric conductivity range of insulators? 10 power of minus 20 ohm inverse centimeters inverse to 10 power of minus 10 ohm inverse centimeter inverse. Next, semiconductors. Semiconductors is 10 power of minus 6 ohm inverse centimeter inverse to 10 power of 4 ohm inverse centimeter inverse. Okay, next, conductors. The resistivity or range of conductors, 10 power of 4 positive plus terminal, 10 power of 4 ohm inverse centimeter inverse to 10 power of 7 ohm inverse centimeter inverse. This is range of, what is range? Electric conductivity range. Like that, resistivity range of insulators, semiconductors, and conductors. These are conductors: insulators, semiconductors, and conductors. What is insulators? The substance which allow the electric current through itself. The substance which can allow electricity through itself, that is conductors. Semiconductors means the substance which can allow electricity partially through itself. Partially means little amount of electricity passes through in itself, that is semiconductors. Insulators means the substance which cannot be flow itself, that is insulators. The example of insulators: rubber, plastic, glass, wood, chair, these type of insulators. Okay, the difference, what are the difference between insulators and semiconductors and conductors? Suppose we have taken three categories: insulators, semiconductors, conductors, and conductors. Insulators, semiconductors, and conductors. Okay, students, first you have taken insulator means the substance which cannot be flow electricity through itself, that is insulators. Suppose these insulators should be insulator, semiconductor, and conductors should be contains two bands like This is conduction band. Conduction band. This is valency band. Conduction band and valency band. Every substance, insulators, semiconductors or conductors should be contains of two types of bands, conduction band and valency band. These valency bands should be contains of number of electrons. These valency bands should be contains of number of electrons. Okay, these conduction band cannot be contains of electrons. The valency band, the distance between valency band and conduction band very large. I mean energy gap very large between. This is energy gap. The energy gap between conduction band and valency band is very large. Energy gap is very large in insulators. These energy gap is known as forbidden zone. The forbidden zone between conduction band and valency band is very large. So the valency band should be contains of number of electrons. To automatically these electrons are not jump to conduction band because energy gap is very large. So automatically to apply some quantity of temperature, more quantity of temperature, these electrons are little amount of electrons are jumps conduction bands, but these little amount of electrons are does not jumps once upon a time. I mean some conditions are applied to itself. These electrons are do not jump to conduction band because of it is energy gap is very large. So this is known as insulators. Automatically increasing with raise the temperature. It means to apply the temperature, automatically electrons or flows increase to valency band to conduction band, but small little amount of electrons are jumps conduction band. Okay, this is insulators. Next we taken as semiconductors. This is conduction band, this is valency band. But valency band should be contains of electrons. This is energy gap is known as forbidden zone. This is okay, students. In the insulators, the energy gap between conduction zone and valency zone is small gap. Is very small gap, not a very small gap, but small gap. But insulators, you have taken insulators, the energy gap between conduction band and valency band is very large gap. To automatically apply some quantity of temperature, these electrons flows this conduction band. So it is also increasing with rise the temperature. Increasing with rise the temperature. You have applied the temperature, automatically these electrons are flow this conduction band. Semiconductors means the substance which can allow electricity partially through itself. Okay, partial electrons are present in conduction bands because you applied some quantity of temperature. This is semiconductors, and you have taken conductors. This is forbidden zone, this is conduction band, and this is valency band. VB, CB. CB means conduction band. This is VB. VB means valency band. This contains of electrons. To apply some quantity of temperature to electrons, this is conduction band, this is valency band. The energy gap, this is energy gap between very small. I mean, there is no gap. It's presence of some quantity of gap, but there is small gap, smallest gap. So you applied some quantity of temperature. These automatically, you have not applied the temperature. These electrons are flows itself. Valency band to conduction band. Why? Because there is no gap, energy gap. So these electrons are between these conduction band and valency band attached to each other. So these electrons are passes through valency band to conduction band. In case you have applied some quantity of temperature, these electrons are applied some quantity of temperature. Before applied temperature, these electrons are flows through this type of particular order. It means uniform. According to the Lorentz and Drude equation, electricity, this is cross sectional area. The electrons would be passes through particular cross sectional area to equal energy of equal levels is uniform direction. This is electricity. So in the conductors, the electrons are flows particular order, but if you applied some quantity of energy, the automatically this energy is increased to gain some quantity of temperature. Why? Because you are applied some quantity of temperature, these electrons gain temperature, flows different directions. It means random. So these electrons is not suitable to temperature, so it is decreasing, but it is increasing. It is also increasing, but it is decreasing with rise the temperature. Conductors means the substance which can allow electricity through itself, that is conductors. Okay students, this is insulators, semiconductors and conductors. Okay, first of all, you have taken insulators. Insulators are, you know very well, rubber and glass, wood, chair. This type of insulators are present in our society. So insulators are need not to us, but you are taken semiconductors. Very most important question in the semiconductors, that is, suppose semiconductors means the substance which can allow partial electricity through itself. Semi means partial. The substance which can allow partial electricity through itself, that is semiconductors. In our periodic table should be contains of semiconductors is that is metals, metalloids and non-metals. Metalloids are semiconductors. What are the metalloids in our periodic table? Like fourth group of elements. 14th or fourth group. What are the fourth group of elements? Carbons family, like carbon, silicon and germanium and strontium and plumbum. These are fourth group of elements. These fourth group of elements are semiconductors. Suppose you have taken semiconductors like silicon. Because of the fourth group of elements, the electronic configuration of silicon 1s2, 2s2, 2p4, and we mean 2p2, this valency ns2, np, ns2, np2, n minus 1 into p2. This is electronic configuration of semiconductors. The valence electrons are present in the semiconductor is 4. The valence electrons are should be contents of semiconductors is 4. Silicon, suppose 4 valence electrons. This is silicon, 4 valence electrons. Silicon, 4 valence electrons. Okay, students. This is silicon, 4 valence electrons. Suppose this silicon, semiconductors applied some quantity of temperature. It means these semiconductors electrons flows valency bond to conduction bonds. These semiconductors of semi elements or semi metals is react with some different groups of elements, and this it means these semi elements are attached with different group of elements. These mixing of element to gain some quantity of energy, that is semiconductor. Okay, students, what type of elements to attached, what type of elements to react with these semiconductors? The first fifth group of elements and third group of elements. What are the fifth group of elements? Nitrogen, phosphorus, arsenic, and antimony like strontium, bismuth. These are fifth group of elements. These fifth group of elements, the valency electrons should be fifth group of elements. First of all, these 4 electrons to each, these electrons, the valence electrons is react with neighbor electrons like this. Okay, students, these type of valence electrons should be react with okay, students, this is valency bonds. This is these valence electrons react to each other, but these silicons are gain some quantity of energy to attain semiconductors. It is react with some quantity, some type of elements like fifth group of elements and third group of elements. In case fifth group of elements to react with silicon, suppose nitrogen is enough because of it is gas. You have taken phosphorus, or you have taken arsenic. Suppose arsenic, the valence electrons of nitrogen, nicogen family, arsenic is 5 electrons. Because of nitrogen, the valence electrons is ns2 np n-1 into p3, total 5 electrons, valence electrons. So extra electron. Suppose attached with fifth group of element. Suppose arsenic is attached with this place. The silicon is left from this structure to its 4 electrons. Suppose the silicon should be contents of 4 electrons. 1 1 1 1. These 4 electrons to left. Its place is add arsenic. 5 electrons should be valence electrons. Remaining 1 valence electrons. Okay, students. Arsenic, because this is arsenic, yes, 5 electrons. These 4 electrons should be react with 4 bonds. Remaining 1 electrons is extra. These electrons is remaining, it is means negative terminal. Okay, students, in case these elements should be contains number of valence electrons. These valence electrons are bonds neighbor atoms. Remaining electrons are negative position. So this type of conductor, remaining valence electrons are contains conductors. This type of conductors is known as negative, n type of semiconductors. What is the n type of semiconductors? The semiconductor should be react with the fifth group of elements to react with fourth group of elements to forms n type of semiconductors. Fifth group of elements to react with fourth group of elements to forms n type of semiconductors. Why this is this reason? These fourth group of elements valence electrons are 4, fifth group of elements valence electrons are 5. These 4 electrons are gains 4 electrons, remaining 1 electrons are extra. These electrons is negative charge, so this is n type of semiconductor. N means negative. Okay students, n means negative. Okay, next you have taken these place third group of elements, like that. What are the third group of elements? Boron, aluminum, gallium, indium, thallium. Suppose you have taken this place third group aluminum. These aluminums react with semiconductors like silicon. Suppose these silicons is left. Why? Because this left, this aluminum is added with silicon, I mean fourth group of element. The silicon is left from this structure to gain these 4 electrons. So this place is adds aluminum. The valence electrons of third group of elements is 3. Only 3 valence electrons. These 3 valence electrons are present in the aluminum. So one electron react with itself, another electron. Remaining it is vacant. Electron. This is bondless. This is bondless electron. Why? Because they have no electrons. These 3 electrons are woven. It has empty place. It is known as hole. How to frame the question? Holes are formed which type of semiconductors? The holes are formed which type of semiconductors? Okay, holes are formed is which type of semiconductor? Third group of elements react with fourth group of elements to forms holes. These hole means 1 to 1 electron. It has no electron, so it is low electrons because of in this structure, I mean fourth group of elements extra 1 electron, but these fourth group of elements react with fifth group of elements. Fourth group of elements react with the fifth group of elements. In the fourth group of element structure, they have no electrons because of negative. These fourth group of elements react with the fifth group of elements. Extra 1 electron is remaining, that is bond electron, so it is positive. So p type of semiconductors to forms. P type of semiconductors. How to frame the question? P type of semiconductors are present in which type of elements is react with the P type of semiconductor forms? Third group of elements react with the fourth group of elements. Why should be these third group of elements react with fourth group of elements? Automatically extra 1 electrons are remaining in the fourth group of elements, because third group of elements should be contains of 3 valence electrons. Fourth group of elements contains 4 valence electrons. These 3 valence electrons is bond with 4 valence electrons. Remaining 1 electron is vacant. These vacant electrons to forms hole. Holes are present in the P type of semiconductors. In case fifth group of elements to react with fourth group of elements, these fifth group of elements should be contains of 5 valence electrons, but fourth group of elements should be contains of 4 valence electrons. These 4 valence electrons and two bonds with 5 valence electrons, remaining 1 electron is less in the fourth group of structure, so it is negative, that is n type of semiconductors. Okay students, P type of n type of semiconductors and P type of semiconductors. P type of semiconductors to forms third group of elements react with fourth group of elements. N type of semiconductors forms fifth group of elements to react with the fourth group of elements. This semiconductors forms is known as process is doping. These semiconductors are forms, this process is known as doping. These what type of elements to presence in the fourth group of elements, that is dopant. Suppose these places adds with arsenic, that is dopant. These places adds with aluminum, that is dopant. Dopants are forms doping structure. Doping. The P type of semiconductors or N type of semiconductors are mostly used in diodes and transistors. What are the uses of p type of and n type of semiconductor, students? These p type of and n type of semiconductors are present in uses in diodes forms and transistor forms. Okay students, this process is known as doping. The elements react with fourth row films is known as dopant. Okay students, some question. Hole is forms which type of semiconductors? That is p type of semiconductor. What is the p type of semiconductor? The fourth group of elements to react with the third group of elements to forms p type of semiconductor, because fourth group of structure is vacant one electron. Next, the extra one electron. How to forms of n type of semiconductor, students? Fifth group of elements to react with the fourth group of elements, because the structure of fourth group of elements is vacant one electron, because it contains of one extra electron. Okay students, thank you for watching. Please subscribe my channel and like it.